Hello and welcome. I'm Hossein Soleimani, ESRC Sub-Expertise Project under supervision of Professor Rozgovan and Professor Giroglu, and I want to talk about what's going on in my project. It might be interesting to you that my project is about understanding the behavior of a bolt. I know what you are thinking about now, but it's not as simple as it seems to be. You may think that bolt is just an unpermanent joint that connect two parts to each other. Despite it seems to be rigid, too many complicated behavior is going on over the contact region due to friction between two surfaces. These two parts, in working condition, may speak, separate, slide on top of each other, or even combination of all of them at the same time. Bolted connection is very important in too many engineering applications like construction of tower and bridge, gas and wind turbine, and even in piping, because it gives the opportunity to assemble a megastructure by using more small and easily manufacturable substructures. These small bolts affect the overall behavior of a huge structures. It may produce lots of noise, increase or decrease the vibration level, or even it may cause to collapse the whole structure. That's why it's necessary to study a small piece of the whole structures in detail. But how we model a bolted connection? By using some mathematical model like harmonic balance and finite elements, we can model the structure. But for modeling a joint, we need more complicated elements that distributed over the contact region. And the parameters of those models should be identified by using real experimental data. So we need identification. Identification actually is like examination that medical doctors do. The doctor examines the patient to decide about health of them. It might be interesting to you that we, engineers, also examine, but instead of human, our patients are some ugly huge structures like gas turbine or aircraft. For example, in echo test, doctor tells you to get deep breath, and by using some instrument, they measure your heart response in that special situation. At the end, your health is checked by looking at these plots. The same story happens here. As we cannot talk to the structure, we force them to behave like we want, by impact hammer or shaker. And then by using accelerometer or laser vibrometer, we will end up with these beautiful plots. In this project, we developed the mathematical tools to understand the bolt joints by using these plots. The general idea of the method is like subtraction. Consider a general coupled structure like these potatoes. We measure the coupled structure response in certain conditions. Then by subtracting the substructure dynamics, which is modeled separately from the coupled structures, we can identify the joints. At the end, we have a mathematical model and a special parameters that can predict the vibration response of the bolted connections. Thank you all for watching and your attention.